Hey everyone, welcome back to TechOps tutorial. In part 1 we have covered the theory of ConfigMap and secrets. If you haven't seen my earlier video, I highly recommend watching that first. You will find the link in the description and also I will add it in the card above. Today in part 2 we will get hands-on by creating them in Kubernetes using both the CLI and YAML and testing how they behave in real pods. We will also see what happens when you update them, whether pods pick up the changes instantly, and why mounted files behave differently from the environment variables. So let's get started. As you can see on my screen, there are some steps I have mentioned here. We are going to see in detail. Let me zoom first. In first step, we will start the Minikube and clean up the old resources. And next, create the config map via CLI, create the config map via YAML, and then create a secret via CLI and also with YAML. Use config map and secret as environment variables. Update the behavior for the environment variables. Use the config map as a mounted files. Update behavior for mounted config files. We are going to reference this with step 6. Use secret as mounted files. This we are going to refer with the step 8. Just we will compare it. And the last step is to clean up. Remove all the tested pods, config maps and secret to keep cluster clean. So let's move on to the terminal. Let's see if I have already started Minikube. Minikube is already started. Make sure we have a clean environment, Kubernetes environment before we start. No old pod, service or config interfering. So you can run kubectl delete all -all. This will delete everything. We are starting with a clean Minikube cluster, so we are all on the same page. If you have already got one running, you can skip this step. kubectl cluster info. If you see cluster info, you are good to go. So let's create a config map. We will start with a quick imperative method, creating a config map directly from the CLI. kubectl create config map. I will give app-config as a name. Next, give from literal app. I will give color. Production. So this is created. Here we are creating a config map with a name app config directly from the CLI. We have given it two key value pair, app color equals to blue, app mode equals to production. Config maps are used for non-sensitive configurations. So this data is stored in plain text inside the cluster. Let's verify the config map. kubectl config map. We need to give the same name. -YAML. So under the data, you can see app_color is blue and app mode is production. These values are exactly the same as we provided. No encoding, no encryption. Config maps are simple plain text key value storage. Kubernetes also add metadata like creation timestamp and resource version for internal tracking. So optionally, if you want to check extra like kubectl, by using this describe command, ConfigMap, and provide the ConfigMap name. Here you can see the data has app color blue and app mode production. This will show the keys, values and metadata in a more human readable format. ConfigMap are great for storing non-sensitive application settings. They are quickly to create from CLI for testing or troubleshooting. But in real projects, we often use YAML files for version control. We will cover that next. So let's create a YAML file. I will give app configmap.yaml. So first let's add API version. Kind will be ConfigMap in our case. Metadata, I will give app config YAML. App underscore color equals to green. Here we will give development. Let's save it and apply. Before applying, let's see the YAML file. In this YAML, we are defining a config map called app-config-YAML with two key value pairs. App color is green and app mode equals to demo. Unlike the CLI method, this declarative approach is stored in a file, meaning we can keep it in Git, review the changes in pull request and apply it consistently across the environment. Let's apply the YAML to the cluster. This creates or updates the config map based on the file we wrote. So let's verify it. kubectl config map, give the config map name, config dot under the data you can see the keys and values. This confirms Kubernetes stores exactly what we define in the YAML file. If you compare the previous step, the only difference is how we create it. The resulting object is the same. kubectl for human readable, we can also use this command by using describe config-YAML. This command is useful to quickly see what's inside without reading a YAML output. CLI imperative is faster for one-off testing. YAML is a declarative, is better for version control and automation. Both method creates the same type of config map. It's just about a workflow and maintainability. So let's see the next step. Next step is a secrets. Create a secret via CLI. Secret works just like a config maps, but the values are stored in base64 encoded format and intent for the sensitive data. kubectl create secret generic db hyphen secret hyphen CLI. This I will give the name. The next is from literal db. I will give db user is equals to admin. This is the value. From literal db pass equals to, I will use super secret 123 and press enter. We have missed hyphen here. Let's create once again. From so secret is created via CLI. This creates a secret named db-secret-CLI with a two key value pairs, db username equals to admin and db password equals to super secret 123. Just like a config map, we can create a secret directly from the CLI for quick testing. The only difference is that the Kubernetes stores these values in base64 encoded form. Let's verify it. Use the same command, kubectl get secret, use the name db-secret-CLI -o YAML. See under the data session, you will notice the value aren't in plain text. That's because Kubernetes encodes them in base64 for storage. Copy the encoded output. If we want to decode it, we have given an admin. So first check the user. We'll give echo, give this to base64, decode it. So similar to this, let's echo the password. You should get the same password which we have mentioned here, super secret 123. Base64, decode it. You received the expected output. That's our DB user value and the DB user password. Kubernetes encodes it, but it's not a security measure. It's just a storage format. Similarly, decode a values directly from the Kubernetes using JSON format. You can run kubectl get secret db, give the secret name -o JSON path, we are getting the data from the data section. So dot data dot, I will use db username first, and then pass it to base64 -- decode. Double quote is missing. I can type a mistake. So you have received the expected output, admin user. So let's see, similarly to the password, just you need to remove this dot data dot use db pass. You received the password. These are the two methods to decode a values. One is a manual method which I have shown here, and the other method is this: decode a value directly from a Kubernetes. This is a JSON path method. Base 64 encoding is not encryption. Anyone with the access to the cluster can decode it. Use Kubernetes secrets for sensitive data, but combine with RBAC, role-based access control, and possibly external secret manager for higher security. So let's see the secret via YAML format. db-secret.yaml. So let's add API version v1, give kind as secret, metadata, I will give hyphen. We are creating this with a YAML. That's why I am giving the db-secret-YAML. So type opaq string data. Here we will give db user demo user, db pass will give my password 123. Let's save it. Let's see the file first. So here we are defining the same secret but using the YAML instead of CLI. Notice I am using the string data instead of data. String data lets me write the values in plain text. Kubernetes will automatically decode them into a base 64 when storing the secret. This is much easier to write and read them manually, encoding the values yourself. So let's apply it. kubectl apply -f. No kind. Okay. Let's reapply it. Okay, this has been created. Now let's verify it by the same command, kubectl get secret, give the name db-secret YAML -o YAML. Here you can see in the data session, even though I wrote a plain text in YAML, Kubernetes has stored it in encoded form. This is the same format we saw earlier when creating the secret via CLI. So let's decode and check the values. kubectl get, you can use this method or the previous method. Manually you need to copy paste the values like this. Secret -YAML JSON path equals to. If you are not able to remember this, you can go with the simple method by manually typing the encoded output as shown above. .data give db pass and then base 64 decode my password -123. Similarly, check the username. So you received the expected output, user demo and the password. This is what we have added here in YAML file. CLI method is quick for ad hoc secret. YAML method is better for version control and repeatable deployments. Avoid storing a real credential in Git. Use a placeholder or an external secret manager in production. So let's see the next step. Step 5. Use ConfigMap and secret as an environment variables. Okay. So let's see how to use ConfigMap and secret as an environment variable. Let's create a YAML file, env. I will give demo pod.yaml, API version v1. We will give kind as a pod. And metadata env demo pod. So let's add it as a name. And next is, let's add a specification, SPC containers. I will give demo containers. Image will use busybox. Command sh -c env sleep 3600. Close this. Env from here we will give ConfigMap, give the reference name will be app config, secret reference name will be db secret. Okay, I will be sharing these all YAML files in description, so you can get it from there. kubectl. Let's see what I have written first. Now let's see how to inject our ConfigMap and secret into a pod as an environment variable. With env from, we can pull all keys from a ConfigMap and secret and make them available as a variable inside the container. This is really convenient, so no need to define extra variable manually. So let's apply the pod, kubectl, apply the YAML file, env demo. Cannot be handled pod, no kind pod. Okay, this has been created. So let's see, kubectl get pods. Let's wait for a second. By using -w, you can continuously watch. No need to enter the command repeatedly. The status shows that create container config error. Let's see the logs. kubectl logs. Give the pod name. Container demo Pod is waiting to start. This is the error. Pod creation is waiting to start the container config error. So whether the reference of a config map or a secret in pod specification, it must exit beforehand. Otherwise the pod cannot even start. So let's check. We have already created secret in above step. Then why it is not picked up the same? So we can check kubectl. Let me cat the file first. We have used app config and db secret. Kubectl get secrets. The mention name is not available here. Our pod was looking for a db secret, but it is not available. Either we can update the YAML and reapply it, or we can create the secret for db. So let's fix it. We have two options, as I told. One, update the YAML file. Another option is to create it. So if I update the same, app-secret and db-secret. CLI kubectl apply-f pod updates. We need to delete the existing pod. Give the pod name. This will take some time. So no resource found. Apply it now. So this has been created. Let's see kubectl get pods. Again container error. Kubectl get secret. Kubectl get secrets. Kubectl get pods. Deleted kubectl. Delete pod. Okay, now it's running. There was some typo mistake. So I will also show you the another option. You can create kubectl create secret generic db-secret from like this. Also you can create, as we have seen in previous step. From literal db you can give a password like this 123. Like this also you can create it. For now I will create one. From literal and -- literal. So this is created. This is the command. This is the second option, but there was already created, so I have used the same thing. in YAML file by updating the YAML file. This I have updated db-secret-cli. Earlier we have mentioned db-secret only without CLI. By this name it was already created, so I have used the same. If you have already created, if you want to go with this step, second step, so you can create this like db-secret without 2 and you can rerun the file. So no need to change anything in YAML file, it will work. So if you go with option 1, you need to update the file and reapply the YAML. I hope you got it. So we can check or verify kubectl c-it get pods kubectl c-it env-demo-pod. So without logging to the pod, we can check the values. So app color equals to blue. So like that we can also check -e for application and db. So here you can see all the ConfigMap and secret values as environment variable inside the container. These environment variables are only loaded at pod startup. If you change the ConfigMap or a secret later, the values won't update inside the running pod. We will have to restart it to see the changes. We will test that in the next step. The step is 6. Update the behavior for environment variable. Okay. So I will run kubectl c-it. So we are rerunning the same env pod. So print the environment. It's a blue. Okay. Right now our pod is using app color from the config map we created earlier. Let's see what happens if we change that value in the config map. So let's update the config map value. kubectl create config map from literal. I will give red. Previous value is blue. App mode will give production. -o YAML dry run client kubectl will apply this apply -f. We got a warning because this config map was created with kubectl create earlier. Kubernetes did not save the original config file, so it's storing it now for future apply updates. This is normal and safe to ignore. So we have changed app_color from blue to red. The config map is updated in Kubernetes, but will our pod automatically see the changes? So let's see. kubectl -t so demo pod print environment. So see, it's still showing the old values blue. That's because the environment variable are loaded only when the pod starts. They are not live linked to the config map. So to get the updated value, so we need to restart the pod and check again. kubectl get pods, pod, delete the pod, kubectl. So this will take a few seconds to delete. If we Control C and check the status, so the status is in terminating state. Okay. So the pod is deleted now. So let's reapply the YAML. Before that, I want to show you we are not going to update anything in the YAML file. This is the same thing. Only thing is that we are referring the app config and db-secret-cli. So no changes in the YAML file. Just I am reapplying it. kubectl apply-f. Pod is created now. Check with the same command. Now you can see the value is red. After restarting, the pod picks up the latest value from the config map. This is why file mounts, which we will see next, are often preferred for the dynamic configuration because they update instantly without restarting the pod. So let's see the next step. Use ConfigMap as mounted files. Let's create the file. podfile.yaml, API version v1, kind will be pod, capital P, metadata, name will be file, demo for the pod, specs, container. So here we will give demo container. We'll use image as a busy box. Save this and apply. So, but we have not added let's add a command with sleep. We'll use the same as we have used in previous demo. -c. Here we will ls/etc conf. Okay. Get config/app underscore. I will explain you why I am writing this, and add sleep 3600. So mount the volume mounts, name I'm giving config volume as a name, give the mount, path will be /etc/config. So this I have defined. In containers I will add volume, config volume we can mention ConfigMap, name equals to app config. API version v1 kind pod metadata. Okay, let's see once again. kubectl apply. We will apply the file. If there is any error, we can see on the screen. Okay, the pod is created. So let's verify the files are created inside the container or not. kubectl exec-it. The pod name is file demo pod /etc/config. Okay, let's cat it config color. The output is red. Each key in the config map becomes a separate file in /etc/config, and the file content is the value from the config map. These are not real files from your host. They exist only inside the container. So let's see the next step. Update the behavior for mounted config files. So let's see this. Let's update it. Before that, let's see the app color. Once again, it's red. So let's update the config map. kubectl create config map. We have created this ---- from literal app _ color. Earlier it was red, so we will give yellow from production -o YAML. Just give a try run. kubectl apply -f. Okay, this has been configured. kubectl get pods. So this has been not, the pods are the same. It's showing the red, the previous value only. So let's wait for a few seconds. Let's see if it updated. Still it is showing the same. See the pod. It should not get restarted. There is no any restart of the pod. Check once again. The value is same. We have run yellow. Actually it takes some time. File mounts updates aren't instant. Kubernetes updates the projected volume in the background. This is one of the coolest part. Kubernetes automatically refreshes the mounted config map files it does not restart the container. Instead, it swaps the file contents in place. This usually happens within 10 to 30 seconds. Now you can see earlier it was red, now automatically it been switched to yellow. Notice how the file content changed from blue to yellow instantly without restarting a pod. kubectl, check the pods. It's 9 minutes and 4 minutes. The pod is not restarted. That's the key difference. Mounted ConfigMap files are updated automatically by the Kubernetes. Compare this step with environment variables from the previous step. Step 6. Those only update after the pod restart. So if your application needs config that change often, file mounts are usually the better choice. Let's move to the terminal. So let's see the another step. We are done with step 8. Step 9 is use secret as a mounted files, which we have done now. Let's create a YAML to use the secrets. I will use pod secret -file.yaml. So we can use the same thing, I think. API version v1, give the kind as pod, kubectl, metadata, name equals to secret file, demo, containers, demo container, image, we will use busybox. Everything will be the same, just I will show you once again. ls-l/etc secret. So you can add cat/etc dbuser semicolon and then give the sleep 3600, and the next will be to mount the volumes. Volume mounts. Mount path /etc secrets read only will be true. So add the volumes. Secret volume. Secret. Give the name. So let's apply this. kubectl apply -f pod secret pod version 1 cannot handle. Volumes read only. Let's see kubectl get pods. It's running. You can check kubectl logs secret. You will get the output. This should show the file list and the DB user values. Now run kubectl exec-it demo sh. So ls-etc secret etc DB user. You should get the expected output as an admin. Exit it. Just like a config map, secrets can be mounted as a file. Each key become a file and the values is in the file content. This method can be safer because you can control the file permission inside the container. For example, making them readable only by the application user. Also, if the secret changes in Kubernetes, the mounted file content updates automatically. No pod restart required, just like a config map as per the above demo. Let's see. This is done. Now last is to clean up. Let's clean up. kubectl, we can run one common command, pod env demo kubectl get pods. This is deleted, and then I think we need to delete ConfigMap as well as the secret. So let's wait or press Ctrl C, it will get deleted. Those are all in terminating state. So let's delete kubectl, delete ConfigMap -config. This also deleted. kubectl delete db secret kubectl get secrets. It's always good practice to clean up your test resources after a demo or experiment. This keeps your Kubernetes cluster clean and avoid leaving behind a old credential or a files that you no longer needed. Also, in a real-world shared cluster, leaving unused credential lying around even in base 64 is a security risk. And that's it for the hands-on demo. You saw how to use a config map and a secrets using both CLI and YAML, used them as environment variables and mounted files, and compared how updates behave. Remember, environment variables need a restart to update, but a file mounts update instantly. If you found this helpful, don't forget to subscribe to TechOps tutorial so you don't miss the next Kubernetes hands-on demo. Thanks for watching.